So in this week, actually, we'll see various things like variable declaration, and then how the variables are assigned memory locations, and then simple function callings. And after that, we'll see how they are stored in memory actually. The data type, for specific data type, how the data type variables are stored. Yeah, so let's begin. Firstly, I'll review the previous year questions, and after that, we'll discuss about several other related questions. So this is question number one. So there are four types of variable that are declared here, and your question is which of them doesn't look like a variable. So can anybody answer this? Which of the variable doesn't look like a C variable? So this is the question. So for the first one, I think it looks like a C variable because it doesn't have any special character, right? So special character means that there are some set of special characters that are allowed when declaring a variable. So what do you think? This doesn't have any special character, right? It only begins with a alphabet and it ends with a digit. There is no special character, so this is a C variable. Is this looking like a variable in C? Yeah, this is also a C variable because underscore is allows as a special character while declaring a variable. And how about this? Ampersand is allowed or not? So ampersand is not allowed actually. So this is not a C variable, and underscores are allowed. So this is a C variable. So there are some rules that you have to remember when checking whether a declared variable can be legally declared as a C variable or not. So the allowed characters are letters, whether uppercase or lowercase doesn't matter, and digits and underscores. These are the only allowed characters in a C variable, right? So the first character must be basically begin with a letter or an underscore. It basically, yeah. So the first character must be a letter, and there is no special symbol that can be used anywhere while declaring the variable like ampersand, dollar, hashtag, this minus or dot. This will call cross compilation error. And you cannot also use white space and other identifiers like if, else, this kind of things while declaring a variable, right? So these are the constants that you have to remember while declaring a variable. If you don't follow the constant, there will be compilation error. So this is question number one. Is it clear to everybody? Okay, let's move to question number two. So this is a simple question actually. So everybody I think knows about printf statement, and this is how the printf statement is actually given. Printf percentage %d 5 equal to 5. So what do you think will be printed here actually? So while you print something using printf, you have to see the identifier, what is the data type that is being printed, and what is the operation that is happening on the right hand side. So what do you think is the operation happening on the right hand side? So can you hear me now? So you always have to evaluate this portion 5 equal to 5 while actually evaluating the printf statement. So what is happening is this actually. So let me clarify here. So whenever printf statement is written like this, let's say okay, percentage d, and then just a second, drag it here. Then let's say 1, right? So what will be printed? This will print 1. Similarly, if you printf what will be printed here? Can anybody tell? This is very important actually. So in the right hand side, you are just giving the expression, and this is the identifier, the data type of the evaluated expression, right? So this is simply 2.5, but the identifier, the data type is percentage d. So what does percentage d mean? It means integer, right? So this decimal, after decimal part, this 0.5 will be dropped and subsequently 2 will be printed. So everything can be one expression. So if you, let's say, do this, I don't know what the data type is for now. Let's fill it up later. But let us suppose that this is the expression, right? 5 equal to 5. So what does the expression evaluate to? 5 equal to 5 means it is a true expression because 5 is equal to 5, right? So if it is a true expression, then if I express it as a Boolean value, then it will be true. And but if I express it as integer, then it will be 0 or 1, because true means 1 and false means 0. So if I say the identifier is 0 percentage d, then 5 equal to 5, then basically it will be 1, right? Because it evaluates to true. This is true. True means 1. So as the identifier is percentage d, the evaluated expression will be 1. Correct? So this is how it works actually. So any confusion?
Sir, Boolean means what, sir? The percentage D, sir?
Correct. No. Percentage d means integer, right? So percentage
Identifier
means
means, sir?
identifier means what is the data type you are basically writing in the printf statement, correct? So yeah, so if you write, let's say percentage d, it means that the data type that will be printed in the screen will be of integer data type. So if I say 5 equal to 5, then this expression evaluates to true, right? Because 5 is equal to 5. But true is will not be printed in the screen because the data type that the printf expression writes in the screen is basically integer data type, percentage d. So it actually gets converted into, and that is called typecasting. So that Boolean data type get typecasted into the integer data type, and subsequently 1 is printed in the screen. So this is how you should read the printf statement, correct? So somebody has said, sir, 2.5 is a float data type. Yes, 2.5 is float, but if only you specify it as float, then 2.5 will be printed. So for example, here, if I say printf percentage f, then 2.5, then 2.5 will be printed because percentage f means float, correct? But if I say 2.5 percentage d here, then this 0.5 position will be cropped and only 2 will be printed. Okay, so I think it is clear now. Somebody has said 2, okay, D,
Sir,
C,
my
C.
doubt is
Yeah.
what do we call as identifier, sir, specifically?
Specifically, we call identifier when you say, let's say, int something, then int is the identifier of that particularly declared variable. The data type you can say, right? Instead of
We
identifier,
call
you
Data
Yeah, yeah.
types as identifiers, sir.
Yes, yes, yes. It depends actually. Data type is a more technical term. So yeah, you should use data type. Correct. Data type is a more technical term actually. Used everywhere.
I Identifier is like a everyday language, sir.
Identifier everyday language. Yeah. Okay, so should I proceed? Okay, I think I can proceed now. So this is the third question. Syntax error occurs when the rules of grammar of the programming language is violated. The statements in the program have no meaning. The program gives wrong or undesired output, and some illegal operation is performed. So what do you think will be the answer? So let's start from the below. This looks like the correct answer, right? Some illegal operation divided by zero is performed, or it is some other kind of error, not a syntax error. What do you think? Uh, let's suppose in the program, somewhere in the program, you have this kind of statement. Okay, so it's text box, and then let's say the printf statement is like this: printf, and then percentage d and 0 by 0. So if this kind of statement is there, what do you think will be the answer? This is definitely error because you cannot do 0 by 0, right? So what will be the answer of this? It will
A
basically
runtime error,
correct,
zero division error.
correct. So it is runtime error. It has nothing to do with syntax error. The syntax is correct. If you see correctly, the syntax is correct, but the compiler will throw a runtime error actually. After compilation, it will compile even. After that, when you run it, it will not run. So it is runtime error. So division by 0, this is ruled out, right? So let's look at this third C. The program gives wrong or undesired output. So this has nothing to do with syntax. Even if you write the logic as problematic, then it will give you wrong output or undesired output. So this is not nothing to do with syntax error actually. So this is also ruled out. And the statements in the program have no meaning. So the meaning is not decided by the compiler. If you write something, you have to ensure that it has some meaning in the program. So compiler just checks the rules and actually converts it into uh, binary, machine code, you can say later. Parse trees it identifies and then processes with it. It has nothing to do whether the statement has any meaning or not. If you write wrong syntax, basically, then it will catch it. So everything the compiler has to do is basically on top of syntax. So if the syntax is wrong, compiler will catch it and throw an error. So that is how the compiler works. And how the compiler works actually. So let's suppose compiler is a black box. You go, provide the program you have written into it, and there are some grammar rules of grammar. It actually parses those programs into a parse tree. So this is how the compiler actually transforms the program into a parse tree and make the computer understand the program by converting into parse tree and thereby converting into machine code. So the first step is basically using the rules of grammar to check whether the syntax is correct or not. Otherwise, the parse trees will not be formed in the first step. So this is actually the correct statement. The rules of grammar of the programming language is violated. So you first check whether the syntax is correct using the rules of grammar. So grammar, it is a part of compiler design. So I think it is completely separate from programming in C. But this is how it works actually. So you give the program to a compiler with the existing grammar, rules of grammar, it actually converts the program into a parse tree. And if you do some syntax error in the program, it will not be able to convert it into a parse tree. So this is how the syntax errors are catched. Correct. So this is the correct response. Rules of grammar of the programming language is violated. So any confusion?
Sir, part stream, sir. It's
Ah,
not
ah.
grammar. What is that? What's a part stream?
No, let me write. Yeah. It is called parse tree. So let's suppose this is the program, and yeah, just a second. You give the program to compiler, and this compiler is consisting of your grammar rules, and this with the aid of these grammar rules, the program gets converted into a parse tree. So it comprises of this kind of statements. So let us suppose that there is a part in the program that is basically 2 plus 2, right? Something like 2 plus 2 percentage d, then this 2 plus 2, then you will give it to compiler, then parse tree will be constructed. So how does it look like? We'll see it later if such things are there in the course, but it basically looks like something that you can use some algorithms on top of the parse tree to evaluate the expression. So let's suppose that it's very hard to draw, but here actually. Oh, text box, right? So yeah, let's suppose this is the plus, this is the operation, and from there are two lines, actually arrows. This is one arrow, and suppose this is another arrow, and these arrows actually will point to the leaf nodes, and the leaf nodes will be your this 2 and 2. So this is just an example, simple example of how the parse trees actually look like. But for complicated program, it looks much more complicated. But this is simply a parse tree of how the addition operation looks like. Correct? There are many kind of parse trees that with the aid of this programming language we get to. This is one of the examples. So there are twos and twos are the leaf node, and this is the plus. So you keep on, doing some kind of, can do BFS, let's say. So if you do BFS, you get to know the final answer of the expression. So there are several algorithms actually. We'll study it later, but this is how the things actually work. Right. So this kind of things are called parse trees actually. By parsing the trees, we'll get to know the expression, what it evaluates to. Okay. Okay. So question number 3. It was 2. This is 3 again. This is 3. Okay, there's some numbering error actually. So yeah, anyway, what is the size of int data type in C? So it actually depends on the compiler. So do we agree or not? I think int is 32 bits, right? Or is it 64 bit? Or it depends on the compiler. Actually, this is an interesting question because it really depends on the compiler, and there is something that is pre-decided. That is basically how many bytes a specific data type would be. Okay, so this is always inserted. I mean, everybody knows that from the beginning in the C uh, manual, it is written that CHR card should be of 1 byte. So, but how many bits is equal to 1 byte? That is not decided anywhere. That actually depends on how the compilers are designed. So maybe in limits.h there is a header file in C where these things are written actually. So in this compiler, how many bits equal to 1 byte, this kind of things. So this is actually when you define, let's say, then there is a space that is allocated for this variable k in the memory, and how many bits is allocated actually. Do you know? So for each data type, let's say for character data type, how many bits will be allocated or how many bytes will be allocated? Yeah. So anybody can answer this. Forget about int, but because the answer is actually depends on the compiler. But for character, is there a limit? Do you know?
1 byte.
Correct. So for character, if you declare the character as like this, 1 byte of space will be allocated. But there are various types of character that we'll see later, unsigned, signed character, and how they work inside the memory. We'll see that later. But this is how things actually work. And you should remember that whenever you declare character k or something, any name equal to some character, then 1 byte of space will be allocated. So yeah, so let us proceed. So what will happen if you try to store a value beyond the range of the declared data type of a variable in C? So compile time error, I don't think it will happen, because if you want to compile it, it will compile because you are not doing anything wrong in the program itself. Runtime error, I don't think it will happen, because for runtime error, there has to be some illegal operation like 0 by 0. Okay, so there is either no error or there will be some kind of error, but it will be very subtle, like basically data loss or wraparound. So any of this combination can hold actually. What do you think is the correct answer? C or D? Because A or B are out of question because they are so trivial actually. So out of C and D, only one is correct.
Data loss.
Okay, so yeah, data loss, we'll see how the data loss happens, or no error actually. I think so other people. Okay, C data loss. Okay. Okay, so it is data loss, and how to understand that it is data loss actually. Let us understand it with an example. Or we can see example later also, but yeah, let's just see it right now. So let's suppose this is your digit actually, some kind of, let's suppose this is the digit. So what does it mean? 1111. So this is 1 into 2 to the power 0, right? So 1, this is basically your, the decimal equivalent of it is 1 plus basically 2 to the power 0, correct? Plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. So what is it? This is basically your 1, correct? This is 2, this is 4, this is 8. So 8 plus 4, 12 plus 14 plus 1, 15. So this is how 15 is represented in binary. So let's suppose that you have declared one variable as 15. So int a, second, there is some problem. Int a equal to 15 and int b equal to 1. And you already know that the compiler only accepts 4 bit of signed integer, sorry, unsigned integer. Okay. So what will be the addition actually? So there is another operation, c equal to a plus b, and then you just print percentage d c. Okay, so these are the operations that are performed here. What will be the value of c here? What is the value that printf will print to the screen? Okay, let's see that actually. So this is 1111 and this is actually state 15, and what will be binary equivalent of 1? It will be 0001, right? So if we add them together, these two things, what will be the addition? I actually showed you the addition, how the binary additions are performed in the next previous week. So this is how the addition will look like. So 1 plus 1 will be 0, right? Here it will be 0. After that, 1 will be the carry. So 1 plus 1 again 0. So then 1 will be the carry. This is 0, and 1 plus 1 0. This is 1, correct? So this is how it will look like. But already I have instructed you that the compiler only accepts 4 bit as an integer. So it actually considers this rightmost bits. So this 0, 0, 0, 0, and then it actually crops it this one because only 4 bits are considered. So what does it evaluate to? 0, 0, 0, 0, which means 0. So the print statement will print basically 0 instead of 16, right? Because 16 requires 5 bit to represent. Is it clear actually? You, why it is not 16 but it is 0? So
Yes,
this is
sir.
basically, this is example of a data loss, right? Correct.
Sir, is
So
it like overflow, sir?
yeah, it is overflow, correct. So basically, if you are having one digit as the last digit, the compiler can handle, right? For this example, this is 15 because it is unsigned. It does the leftmost bit is not the signed bit actually. So in this case, 15 is the highest integer on 4-bit values. So if you just add b, which is equal to 1 with 15, then the corresponding value will be 16, but you cannot represent 16 in a 4-bit system. So that is why the print statement will give you 0, because the leading 1 will be cropped and only the leftmost 4 zeros will be there, and 0, 0, 0, 0 means 0 basically. So the print statement will give you 0. So it is kind of a data loss. Overflow is integer overflow. Is it correct actually? I mean, is it understandable?
Yes, sir.
Okay. Okay.
Sir, will the compiler tell, sir, that overflow has occurred like that?
What, sorry, can you repeat the compiler?
If we run this program after giving 0, will it tell, sir, like overflow has occurred like that? Will it specify, sir, that compiler?
No, 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 no. It will not specify anything. It will just print 0. So it will do the operation as it is. It will just, remove the last one that it has here. Okay. Because the compiler can only accept, the machine can only accept uh, 4 bits as the integer variable. So if you declare it, 4 bits are allocated inside the RAM for, allocating one particular kind of variable. So for integer, let's suppose it is 4 bit. So on one part of the RAM, only 4 bits are allocated for defining that particular integer. So when you just do it like that, okay, so it will just print 0. So there is another problem in the program I wrote. What is the problem? Can anyone catch? Actually, it will not even compile. So actually, I did not declare the variable C, right? So you have to declare it beforehand. Yeah. So let me proceed actually. So the answer is data loss or wraparound. I think by the example, it is clear now how it is happening. So what is typecasting in C? This is another question. Assigning value to a variable, converting a variable from one data type to another, defining a new data type, and initializing a variable with constant value. So these are the 4 options.
Option B.
Okay. So
Option B.
option B. Okay, so I think everyone is saying option B. Okay. Yeah, yeah. Yeah, so everybody is saying option B. So let me clarify why it is option B. So what do you mean by typecasting? So let us suppose that you declare a variable in one integer, one data type, and then you try to print it. But while printing, you see that you should convert it into some other data type, let's say. So then you do the typecasting, or there are many other reasons actually you need to do typecasting, but it is basically converting a variable from one data type to another. So this is the right uh, answer actually. So let me Let's clarify it here. So int so 5, and then you print it like this. The value that will print will be 5, right? Similarly, let us suppose you print it like this. It's a 5.5 and it is float, let's say. So if you just write it like this, f will be 5.5, right? Because it is floating. But if you do d and then if you print it x, then it will be 5 because the decimal part will be stripped up. So why it is happening actually? How the compiler knows that the floating point and decimal, I mean the integers are different? It knows because it actually converts them, typecast them from one type to another. So if you just write int x equal to 5.5 and then basically printf percentage d and then x here, then it will basically print you 5 because the decimal part automatically gets typecasted from float to integer while you declare it. So underneath what is happening is basically this. So float, there is a kind of data type that is getting created that gets converted into int. So this is the data type of this is float. So it gets converted into int, and then this x is basically typecasted like this. Then this is assigned to x again. If you do this operation like this, so this implicit typecasting is happening. Because of that, while you printf percentage d, 5 is getting printed as now 5.5. Similarly here also, when you assign it is fine, but when you print it using percentage d, automatically this 5.5, this float value is getting typecasted into integer. So this is how the, I mean, you convert from one variable from one data type to another, and this is called typecasting. Okay, so this is how it happens underneath when you declare one data type by assigning variable of another data type. Okay, so this is question number 6. So yeah, define fun x like this. You are has defining as a macro. You're defining the function. I think everybody knows what a macro is. I'll clarify it later. But assuming that you know what a macro is, this is the program that is given. And the main function, you are declaring one variable I, which is a float data type. And this is the operation that you are performing, 64.0 divided by fun of 2. And you are printing up to 2 decimal point. And this is the printf statement and return 0. Okay, so what do you think will be the output? So
16.
do it. Okay. Any other people? Let me check. Why it is appearing every time? Okay. 16. Okay, everybody is saying 16. Yeah, so it is very simple actually. So what is happening? You just take it, take the value which is passing, getting passed to the function, which is 2. You just do the operation in the function. So function takes the value 2, it performs the operation inside the function, which is x times x, so the 4, and it will return the value of 4 here. And 64 gets divided by 4, then that is assigned to I. Correct. So this is the flow of the operation of how it is performed. So let me clarify for those who are not aware of how the function actually gets performed operation. So let us suppose you declare a function like this. So some has defined maybe some kind of f x, then x star x. So in the main function, if you call it like this, let's say, so just a second, the int main, Just let's say call it like this, integer I equal to f of 2. So what happens actually? This value 2 actually gets here, right? Right. So what is, if you just assign the value of 2 here, then what the function evaluates to? It is evaluates to 2 into 2, which is equal to 4. So integer I will be equal to 4. But instead of storing that value to a variable, what you are doing that you are just using it as a denominator of this function. So float I you are declaring as a variable, and I equal to 64.0 divided by fun of 2. So fun of 2, when you pass the value of 2 as the parameter in the function, it will evaluate to 2 into 2 equal to 4. So instead of storing that value of 4 into another variable, you are just placing it as the denominator of this function, and 64 by 4 is 16. So 16 is assigned to this variable I, and when you are declaring it, it will be 16.00 because it is a floating point number and you are assigning up to 2 decimal point. So 16.00 will be printed. So I think it is very simple actually to understand how the parameter passing happens inside the function. Okay, I think it is clear, right?
Yeah.
Yeah.
For the function, we don't need to specify the data type, sir, like integer, int function x, like that.
Correct. You need to define. You need to define it, but only when it is not a macro. It is defined as a, normal function. Okay. Then you need to define what is the data type of the return type of the function actually. That we have example of later. But this is defined as a macro actually. Okay. So as has defined, I have defined it because only one line function is there. This is okay.
Macro means no need to specify data type, sir.
Correct. In macro, you don't need to designate any data type. Okay.
Again, one more doubt. That 2f is
Yeah.
there now, sir. 2f.
Yeah. This one, right?
Sir, percentage of means decimal value. This 2f specifies what, sir?
2f specified actually how many digits will be printed after this decimal. So this is the point, right? And after that 0 is printed. So there is only 2 digits that are printed. So that is specified by 0.2f actually. If you see carefully, it is not 2f actually, it is 0.2f, percentage 0.2f. So it means that after this point, there will be 2 digits that are present. So instead of, let's say 2, it is 0.3f, percentage 0.3f, then it will look like this. The output would have been looking like this, correct? Or it is, let's say percentage dot 4f, then it would have been looking like this.
If
Okay,
no number specified means many zeros, sir.
many zeros, yeah, like this it will print actually. How many bits are available, based on that it will print. Any more doubt for anybody?
No, sir.
No, sir.
Okay.
No, sir.
Yeah, so I think I can proceed then. So this is another question, and so the question is that if this is the, just a second, I think the numbering gets messed up actually. Anyway, forget about it. So this is a question, and this is the integer. Can you see the screen actually properly? Should I change it? Yeah, int a equal to 5, b equal to 10, and these are the operations are actually performed. So, and after that you are printing a and b. So what is the uh, output actually? So this we have to tell. So integer a equal to 5, b equal to 10. So there will be two integers that will be declared here. Text box. So this is your A. Basically, this is the memory location where 5 is stored and it is indexed by A. Shape, I think it is shape, it is text box. So it is A, and similarly, this is B, correct? Just a second, this is B. So these are the two things that are declared. This is 10 actually. Then what is happening? See carefully, A equal to A plus B. So the operation A plus B, what does it mean? The value assigned to A and value assigned to B will be summed, that is 15, and that value will be stored in the memory location addressed by A. So it will be 15, right? So is it clear how the first line actually looks like? Why it is 15? Because previously the value was 5. At memory location addressed by A, the 5 value is stored. At the memory location addressed by B, value of 10 is stored. Now it performs the operation A equal to A plus B. So the value addressed by A and B, this part, A plus B, this will be summed up. And what is the value? When you sum it up, it will be 15. That value will be stored in the memory location addressed by A. So here 15 actually comes. So the line number 1 is complete. We go to line number 2. Now see the value addressed by A and B. So it is 15 addressed by A, and the value of B is now 10. So you just take the subtraction and assign that value to memory location addressed by B. So A minus B is what? 5. So you place the value of 5 in the memory location addressed by B. So it is 5 now. Okay. Now you are going to the third line. So it is A equal to A minus B. So again, you are seeing the memory location of A, it is 15. For B, it is 5, and you are taking A minus B. So it is 15 minus 5 equal to 10. You are assigning that value 10 to the memory location addressed by A here. So you are moving 10 here. So after this operation are performed, what is the value of A? It is 10. What is the value of B? It is 5. So effectively what happened? Swapping happened actually. So the value of A comes to the value of B, the value of B comes as the value of A, right? So this is a code for swapping the values of A and B. So this is how it works actually. Is it clear to everybody? How is it happening using the memory location?
Actually, in sixth question, can I ask a doubt, sir?
Yeah, sure.
Sir, here we have defined int main, no, sir. Like data type is int, no, sir, before main. But here we are using floating numbers, no, sir. So, will it be okay, sir?
Why did you define 10? Oh, this
the
one.
main,
No,
sir.
this has
Yes, sir.
this has nothing to do with what is inside here actually. Okay, if you have declared void main, then you do not need to specify anything here after the last printf statement or any last statement. You don't need to specify return 0. But if you are specifying int main, then you have to specify return 0 or return anything actually. So it doesn't matter. These are just formalities. Okay. So if you declare int main, then you have to return a value, which means the compiler will know that the main function has been executed, right? The program will know actually. So whatever you write inside the main function, you write it. It has nothing to do with the data type, the return type of the main function. Okay. They are completely different concepts. So we could have also written the program using void main and without return 0, correct?
So, this code is inside the main, but return type is int, like that. It is not meaning, sir.
Return type of the main is int, but it has nothing to do with what is written inside the main program actually. I mean, just forget about the return type while you are reading a program or writing a program. This is just formality actually. This has nothing to do with what is the thing that is inside the main function, right?
Yes, sir.
So yeah, this is another macro question. I'm going to skip it because you already know what macro looks like. So this is the question number 8. So this is a simple question again. So this is has include stdio.h and then int main and int x equal to 4, y equal to 5. And this is how the question looks like. So if x is equal to 4, then these are the things. Then printf true or printf false actually. So if we want it to be equal to true, then what will be the operation that needs to be performed here?
Option C.
Okay. Okay, so it is very simple question actually, because you just want to see whether it is really equivalent to 4, x is equal to 4 and y is equal to 5. You just test it like that. So x equal to 4 will evaluate to true because x is assigned as a value of 4. So 4 equal to 4 is true. Ampersand means and, logical and operation, right? Then after that y equal to 5. So it evaluates to also true because y is assigned a value of 5. So true and true is true. So if you want the printf statement to print true, we have to assign equal to. So this is a very simple question actually. So any doubt or should I explain more? If you have any doubt, then I'll explain. So let's suppose what would have happened if I would have written it like that. Like this, let's say, the first operation. Percentage, sorry, equal to and not equal to. Then what would have happened? X equal to 4 means it
False.
will, correct. X equal to 4 means it is true. Ampersand means and y not equal to 5 means it is false because y is assigned a value of 5. So true and false is what? False. So that is why this statement basically will return you false. So like this, we have to see the answer. I think it is very easy. So if anybody has any question, then I'll proceed. Okay. Mm, okay, there are lots of questions remaining. So I think it is very simple. What is the purpose of return statement actually? So there are 4 options. The correct option is to exit a function and return a value. Okay. So this is a simple thing actually. You are not using return function to declare a variable because they are declared using declaration statement like int x equal to something like that. Terminated loop. No, you are not using return type to terminate from a loop because if you use void statement, there is no point of using return, right? To end a program. No, this is not correct because inside a function you can use a return type, and after that function you can call other part of the program, and it is not ending. So this is not to end a program, not to terminate a loop, neither to declare a variable. So the only option is to exit a function or return a value. Correct? Okay. Yeah, so this is another question. This is another very simple question actually. What is the output of the following code? See it carefully. This is an interesting question actually. Hmm?
Then
It's 5, sir. 5 only.
It is 5 or 10?
5 because it's a void, not returning anything.
Somebody is saying 5, somebody is saying 10. So yeah, let's wait for another 30 seconds. See. Guys, please type in the chat box whatever your answer is.
Question not visible.
Yeah, sure. Okay. You can see. Okay, I think let's see the answers now. Most of the people are saying 10, somebody is saying 5. So let me clarify what is happening. So when you declare this variable, what happens is that, let's see step by step. So here, this is the thing, then insert. This is a text box. Okay. So when you declare this int a variable, this is the a, and it will be allocated a box basically inside the memory. So a is the location addressed by the variable a, and this is the box inside the memory where the value 5 will be written. After that, there will be another box where this function is basically stored. So what does the function actually takes? It takes the integer x and it does the operation x into x. That's it. So if you pass the value 5 to this function, then it will perform the operation and it will store the operation 5 into 5, 20, sorry, it is x into 2, right? So it will store the value x into 2 somewhere and just it will store it. That's it. Then you are printing the value a. So what is the value a right now? If you see carefully, it will print the value addressed by a, which is still 5, because you are passing the value when when a actually the value 5 is getting passed here, and it is the value basically is written as 10, but it is assigned another location in the memory. It has nothing to do with the value that is addressed by a, correct? So it is still 5. So when you print a percentage d equal to percentage print a percentage d a, the value addressed by a will be printed, which is equal to 5. So yeah, the answer is 5 actually, not 10. Is it understandable or should I explain it? Okay, let me explain it again actually. So in the memory location addressed by a, the value 5 is stored. Now let's suppose you call the function, which is basically this. So what happens is that when you pass the value to this function, then 5 basically gets passed, because func of a means whatever value is addressed by a will be passed to the function, which is basically equal to 5. Then you perform the operation 5 into 2. You write the operation a into some memory location. Let's say that it is z. So in the memory location z, that value 10 will be stored, right? But anywhere in the operation up to this part is performed, in anywhere of the operation, the value of a is changed or not. The memory location addressed by a is still 5, correct? So if you just do the printf of percentage d and a, the value of 5 will get printed actually instead of 10. So what we should change in the program such that the value of 10 actually gets printed. So for that, you need to assign whatever it evaluates to the address, I mean addressed by a, right? So the addressed by a is basically a, and you have to do it like this: a equal to func of a, correct? But in this case also, as the return type of the function is void, it will not return anything. So this is just will get a I mean garbage value, then the garbage value will be printed here. So To cure that, what you need to do is that you have to specify the return type of the function, which is int here, and you have to return here like this, return x. So if you do that, then the value whatever is assigned to the memory location of z, or maybe x, you can say it x, that will be assigned to the memory location addressed by a when you perform this operation. Then the value of a will be updated to 10. Then when you print the value of a, then 10 will get printed. Correct. So this is how the return type from the function actually works. Any doubt about this? Should I proceed? Okay. This is another question. So you are declaring a double type variable and you are typecasting it like this, integer, and this is you are assigning it to another integer variable int I. So after that, what will be the value of I? You are declaring it like this, double D equal to 9.8, int of I equal to typecasted this value, double value to integer, and then you are printing that typecasted value again in a integer data type. So what is the output?
9, sir.
9, right? Yes. So when you just typecast it like this as an integer, the whatever value is after the decimal point will be cropped. Only this part will remain before the decimal point, and that value will be assigned to the integer variable I. And when are you printing it? As it is an integer variable, the value 9 will get printed. Correct. So this is the logic. So any doubt about this? It's a very simple question, I think.
Sir, if we didn't typecast it also, will it give 9, sir?
If you don't typecast it, it will also give you 9. Because the data type inside the printf is %d. So it will be implicitly typecasted into an integer, and then 9 will get printed actually in the screen. Okay. Okay. So how about it? So now you are declaring character variable c equal to, and you are assigning the value of a to this character variable, and then you are doing the typecasting from this character to integer. And what will you get as the output?
65.
Why 65? Can you explain?
Because we will get the ASCII value of the character when we convert it to integer.
Correct. So every character, they are represented as the corresponding ASCII code inside the computer, and then that ASCII code is converted into binary digits actually. So let us suppose this is, so there are predefined ASCII codes for every alphabet letter in the alphabet. So let's suppose that when you declare it like this, character C, correspondingly in the memory location addressed by C, A is not stored like this. Okay, the corresponding value, ASCII value of A will be stored. So this is called ASCII value. This is a unique assignment for every letter in the alphabet to a corresponding double-digit number. So for A, it is basically 65. So instead of A, 65 will be stored. Correct. And 65 will basically get converted into the corresponding binary digit, and then that will be printed here, printed. So the printed value will be 65. Is it clear? Okay. So I think this will be shown later because there are some concepts that are needed. So it later. So question number 13. So yeah, what will be the output of this following snippet? You read it carefully actually. There is a implicit typecasting happening here. So you just give the value of 7 and 2 as the parameter. You pass the parameter with the value of 7 and 2, and this return x divided by y is happening, and all the parameters are of integer type. And this is the final data type is float. So what is the output that you will get? Any idea, anyone? So you just assign the value 7 to x and 2 to y, right? So there are two memory locations. One is addressed by x, that will get the value of 7. There is another memory location which is addressed by the variable y, that will get the value of 2. Then you do x by y. So 7 by 2 it will happen. But see the value basically that you return here. This is integer division actually. This is not floating point division because you are not assigning it to some floating point variable. So what will happen is that it will basically divide 7 by 2, and then it will not print 3.5. It will just print 3 because the return type here it is not assigned anything. So it will infer the return type based on the parameters it is operating on. So the parameters are of integer return type. So it will also be assigned the value of integer. So 7 by 2 here will not be 3.5, it will be 3. But when you return that 3, this is again typecasted back into the data type of float. So 3 will be actually, instead of 3, we'll write 3.0, and then that value 3.0 will be printed here. So there are two implicit typecasting happening. One typecasting is happening here when you return x divided by y. 7 gets divided by 2, then instead of 3.5, you get the value of 3. Correct. And as this is an integer and you are typecasting it back to float when you're returning that value, then it is getting the value of 3.0 instead of 3. So the printf will basically print 3.0. Okay, so this is the output that we'll get. So any doubt about this? So there are two implicit typecasting happening here actually. So if you have any doubt, you can ask actually, I can clarify it. Everybody is saying 3.5 actually, it is 3.
Sir,
Because
again, sir, can you explain
yeah,
again? Sir?
yeah, correct. I'll explain again. Yes. So see what is happening here actually. So 7 you are passing as integer. So the data type of x is what? Integer, correct? This is integer data type, and this is 2. This is also you are assigning here. So the integer data type of this part, the denominator of the operation is also integer. So if both are integer, and if you are dividing an integer by an integer, what will be the return type of that operation? It will also be an integer. The compiler will not automatically infer that you are dividing an integer with an integer, and the operation that comes out is basically a floating point number, right? The compiler will infer the data type first, then it will perform the operation. From the data type, you can see it is both the numerator and the denominator are integer, And if you divide an integer by integer, the data type will be obviously integer because both are integer. By inferring the data type, it will perform the operation, integer division basically. Then what will you get? 7 by 2, you will get 3.5, but as it is an integer division, that 0.5 will be cropped off. Only the 3 will remain, correct? And that 3 value you are returning using a floating point number. The return type is float. So that 3 that you get by doing the integer division, that gets typecasted into float. Then you are returning that float from here to here, and you are printing that float. So it will be 3.0000 like that. Do you understand it? No. Yeah, but the question did mention that the output will be in float value. Correct, correct. It will be in float value, but see the flow of the operation. You give the value here, you give the value here. Both are integer, and you perform the integer division here. The return type basically is of float, whatever you are returning from the function. But before returning, you are performing the operation itself inside the function, right? That operation that is being performed is basically integer operation. The reason is that x and y both are integer type. The return type of the operation will also be integer. It will not be float, because the compiler has no way to know before performing the operation what will be the output of the operation itself. So 7 by 2 is equal to 3.5. We know that beforehand, but compiler doesn't know it. Compiler has to infer the data type first, and based on the data type, it has to perform the operation. Correct? So yeah, I think, is it clear now, or still you have some doubt? If it is not clear, then I can explain, or maybe you can also watch the video later. And if you have any doubt, you can ask. Okay. Okay, so yeah, let me proceed. Okay. Yeah, so this is a question using the pointer. I don't know whether you know pointer about pointer or not. So this is how an array is declared actually inside C. So what is an array? It is a collection of a particular data type, collection of variables of a particular data type, correct? You cannot change arbitrarily the data type like in Python. So you already have to specify the data type of the array, and this is a storage of this data type actually. You can think it like that. So how this array is basically stored inside the memory. So let's suppose this is the memory, and it has only 4 locations, and each location is basically 1 byte. So this is a 4 byte of memory. Okay, so in earlier days we used to have this kind of computer. No, not me, actually much earlier than me, in 1950s maybe. Those computers had 4 byte, 5 byte of memory. So it looked like that, and inside those computers actually you can specify this kind of arrays actually, right? So what is written inside the array? So this is actually the array, let's say. So this is array, and inside the array at the first memory location 10 is written. At the second memory location 20 is written, and the third memory location 30 is written, and these are the remaining part of the memory filled with garbage value. Okay, so these are the garbage value, let's say. So when you write printf of let's say you write it like this: insert text box here, printf percentage d array of 0. So what do you think will get printed here? Array is here. Array of 0 means you are indexing the array. The first position of array is 10. So it will print 10, right?
10.
Correct. Similarly, if you print array of 1, 20 will get printed. If you print array of 2, then 30 will get printed. If you print array of 3, what will you think will happen actually? Array has only 3 numbers, so 3 means the fourth index of the array. So will it print anything or will it throw a compilation error?
Compilation errors.
Correct. So it depends on the compiler, but yeah, a compilation error will be thrown. Anyway, so the reason is that you just index the array like this. 0 means the first position, the second position, the third position, right? And this is the continuous the memory location. We are not bothering about these things. So let us look at the program now. So in the second position, you are declaring a pointer. So this is how the pointer is declared: insert ptr, or ptr is the name of the pointer. You can write anything actually. Okay, so for reference, and this is the name of the array. So you can write anything instead of arr actually. Okay. So let us suppose ptr is the name of the pointer, and it is assigned arr. So what does it mean actually? It means that that pointer actually points to the first memory location of the array, correct? So how does it look like? So this is the first memory location. I have to revolve it. Just a second. Okay. So yeah, this is the first memory location and it is being pointed by a pointer. So what is the pointer here? Pointer is ptr. So what is stored in the pointer? So in the pointer, actually, the location of this array will be stored. So let us suppose, just a second, actually, it has to be very clear, actually. That is why I'm taking so much time. Uh, just a second. There are some problems. Anyway, so insert column left. Okay, so these are the memory location, let's say, and the left hand side, these are the, let's say, the this hexadecimal addresses, right? So I'm not writing the whole address, I'm just writing the location like 010203. So this is the first location, this is the second location, this is the fourth location, and this is the third location, this is the fourth location. So when you store a pointer, when you assign a pointer to the array, what will be stored actually? So pointer, let's suppose, is another memory location in the array, and when you assign it, let's suppose only 4. What did I tell you? I told you that this is only a 4-bit memory, 4-byte memory. And in the first 3 bytes, the first 3 memory locations are basically occupied by the values inside the array, and the fourth memory location is vacant. So let us suppose that fourth memory location is basically your pointer. The pointer gets the fourth memory location, the variable pointer, right? And what will be stored inside the pointer? It will be storing the value assigned by array. So what is the value assigned by array? It is the first memory location of that array, correct? So when we declare ptr like that, ptr is assigned a location of 0x04, the fourth location, only available location in the RAM, and that gets the value of the first memory location that is addressed by the array. So it will look like this. So instead of this operation, forget about this operation. Okay, now let us suppose that you do this printf %d. Just let me zoom it slightly so you can see it. Yeah, so %d, and then let's suppose that it is %ptr. So what do you think will be printed here? Can anybody say? Just look at the right hand side memory table, and from that try to tell what will be printed here.
Sir.
Yes, train will be printed. The reason? So this star
Depth of the
means
first variable
dereferencing.
will be stored.
Correct. So when you declare it like that, right? In this option, you get a memory location by pointer. Let's suppose this is the only available location. So 0x04 is obtained by the pointer PTR, the name of the pointer, and that is assigned the value of the memory location, not the value of 10, because that is how pointer works. When you say insert PTR, then the memory location addressed by the first part of the array, first location of the array will be stored here, so which is 0x01. And then when you see star PTR, that means the pointer PTR is getting dereferenced. Dereferenced means it will print the value that is basically there inside the memory location addressed by it. Carefully see what I'm saying. I'm saying that the pointer holds the memory location 0x01. So when you say star PTR, it will give you the value which is addressed by that particular memory location. So it is 0x01 means when you dereference it using star PTR, the value inside of 0x01 will get printed instead of 0x01. Correct? So it will give you the value of 10. But if instead of star PTR, if you would have printed PTR only, then it would have given you 0x01, because you are just outputting the value that is assigned by the by this actually PTR. And these are the memory locations: A of 0, this is your A of 1, and this is your A of 2. Okay, so this is how the memory locations are represented. And if you do star PTR, then the value that is assigned to the pointer, that is the memory location of A of 0, that value, the 10 will get printed. So I think it is clear. After that, let's suppose unblock these two lines, PTR equal to PTR plus 1. So now what happens? So it is called pointer arithmetic. So whatever memory location the pointer is now pointing to, which is 0x01, it will be incremented by 1. So now the pointer will point to this memory location, the next memory location, which is 0x02. So now inside the pointer PTR, the 0x01 gets updated to 0x02, correct? So now PTR means 0x02. And if you dereference it again, what will get printed? Now we have to answer. What will be the final answer of it?
20, sir.
Well, so let me see what other people are saying. What is the output?
20, sir.
Yeah.
Sir, my doubt is, we have given, sir, int star PTR is given, sir.
Hmm.
It takes the memory location just below the array, sir.
The memory location of the array, actually, I mean the beginning of the array. Correct. So the beginning of the array is 0x01, so it will take the memory location of the beginning of the array when you declare it like that. Okay.
No, sir. My doubt was here given, sir, 0x01, 0x02, 0x03. If we are giving int star PTR, then the memory location will be right below of 0x03, sir, for every case.
No, not necessarily. It can be anything actually. So it can be, let's say, I only said it because the RAM had only 4 bytes. Let's suppose the RAM is a huge RAM. It can be any location. So it can be 0x, then 1, anything like that. Okay. So it doesn't matter really. It can be anything. Understood?
So the pointer address by default takes array's first location, sir.
Correct. Yes. Yeah. So any question regarding this? So it will be 20 because now it has been incremented to 0x02, and if you dereference it, the value of 20 will get printed.
Sir, sorry, sir. One more doubt, sir.
Yes, sure. Go ahead.
If we have not given star, only PTR we have, right? It means it will be like variable, sir, not pointer. It will be only variable
It-
like that, sir.
Correct. So instead of, let's say, instar PTR equal to array, if you would have specified in int PTR equal to array, it would have only given you yeah, actually it will not be a pointer actually. Correct. It will be variable assignment, and it will fail because array is of data type this int this, okay, and this is you are assigning it to int. So you cannot typecast from an array integer variable to simple integer, right? So it will fail actually. Correct.
Sir,
Hmm.
sir, can you re-explain that what is happening in the second step of this program?
Second step means in this part.
Yes, sir. Int asterisk PTR is equal to array.
Oh, this one, right? Correct. So forget about everything. So I think you know up to this portion, right? Please interact actually.
Yes, sir.
You know up to this, right? I mean the first portion, how the array is declared or not. Huh?
Yes, sir. The doubt is only about the second step, means how it is
Correct.
working.
Correct. So let me clarify. So let's suppose that this is the array and this is the array. It is how it is stored in the RAM, and after that there is this pointer. This second step, how the pointer is declared. So when you declare it like that, there will be a variable which is named PTR, and it will get a space inside the memory. And let's suppose it gets a space 133, for example, and this is the PTR. Correct. Up to that it is clear. So this variable is declared, and add as it is a pointer variable because you are assigning a star before its name. The compiler knows that it is a pointer variable, pointer data type. Not data type, it is a pointer type of variable. Then you are assigning which value, the array value. What is array actually? It will know that it actually points to the first location of the array. So array begins from location 0x01, and then this value will get stored in the location addressed by the pointer. So for the pointer, there will be one variable that will be created using this. But when you assign the value of array here, the first location that is addressed by the array, that location will be basically placed at the pointer data type. I mean pointer's memory. Correct. So the pointer will contain the address of the particular location of the array. So the first location of the array. Is it clear now?
Yes, sir. Sir, by default, the first location of the array is stored in the pointer always.
Correct. By default, it is stored.
Yes, sir. Thank you, sir.
Yeah, thanks. Yeah, I think it is clear, so I can proceed, or let's see. Okay. So conceptually, there are only a few things pending. Basically, just let me check if it is recording or not. Yeah, it is recording. It's fine. Yeah, tell me.
The star pointer, is it a type of variable, sir? The star pointer.
Yes, it is a type of variable. It is called pointer data type. Correct. It is called int star actually. Int star means pointer to the integer. Okay. So this is a simple question. Try to answer it. So yeah, you are declaring a floating point type variable C equal to 5.0, and the temperature in Fahrenheit is, you are converting the Celsius into Fahrenheit essentially.
For suppose instar, any other name like instar, hello means that instar hello will also be taken as pointer, sir.
Instar?
Another name, sir, like not PTR, maybe like
Yeah.
POI.
Correct.
Then also
Correct.
will it be
So
like act like pointer, sir?
Yes. Let's suppose it is hello, and then you are dereferencing that hello, right? Then also it will be pointer. So like this you are saying, right?
Yes, sir.
So yeah,
Thank you, sir.
it will be hello. So everything will remain same. 10 will get printed here, and it will print 20. So yeah, convince yourself it is how it is true. Okay. Okay. Yeah. So this is the question. Next question. Floats equal to 5.0, and this is the printf.
Point 00 is the answer. 32.00. Yeah. Can you explain why it is happening? So it is very simple actually. Take the value here, 9 by 5, and then multiply it with C. So what is the value you are getting? You are getting the value of 9 by 5 is basically whatever it is, and if you are multiply, then it is 9.00. Then you are sorry, it will be what? Yes. It is, what is this actually? 37. How it is 37? Can you explain? Okay, somebody has a 37 actually. Can you explain why it is 37? It is interesting actually why it is 37.
It's
I think it
adding
is 41. I think it is 41. But the correct answer is 37. Yeah, everybody is saying 41. See, it's actually it is 37. Okay, so let me explain why it is happening. So somebody in the beginning has said 37. So the reason is, whenever we evaluate this thing, actually, we have to see the precedence of the operation. So 9 by 5, if we evaluate like this, what is 9? It is a integer, not a floating point number. You have not written 9.00, and 5 is what? Integer. So if you divide one integer by integer, the compiler implicitly will know that the division will also be a integer division, and subsequently it will give you the value of 1. Correct. So 9 by 5, it cannot divide like that. So if it is 10 by 5, it would have been given something. But 9 by 5 is basically how much? 1.8, right? So that 0.8 will be cropped up. Only the 1 will remain. So this portion will be evaluated first because it has higher precedence because of the bracket. So the bracket will be evaluated first. After that, what value will get? 1. 1 will be multiplied with the floating point number, which is 5. Then that 5 will be added to 32. That will, so this is floating point number here, 32 is integer. They are added together. This is another floating point number, 32.00. So it will get typecasted from integer to floating point number. Then 32 plus 5 is 37, and you are printing 37 here. So this is how the implicit typecasting will happen, and this kind of tricky questions will be there in the exam also. So you have to know how the operations are performed and what is the type of the operation that is being performed and what is the output that we will get after performing the operation. This you should be very clear of.
Sir, is it like that rule? First, in between brackets, operation should be done. After that, multiplication should be done.
Correct,
Like
correct.
that, sir?
That is true. That is true. That is precedence rule, na? So you should always perform the operation inside the bracket first, even before division and multiplication. So there is a BODMAS, there is a rule, right? So you have to follow that actually. Bracket is the first thing. Then division, then multiplication, addition, and subtraction. So these are the things actually. So if this kind of convoluted question are there, then you have to see the precedence actually of the operators. And after only establishing the precedence, you can actually, yeah, evaluate the expression.
Sir, can you explain it again?
Correct, correct. So 9 by 5, this is the value that you get, that you do first, and then you multiply with C. The reason is that 9 by 5 is inside a bracket. So 9 is an integer, 5 is an integer. If you divide an integer by an integer, the compiler will know that you are doing integer division. So it will assign the value of 1 instead of 1.8. So if you want 1.8, then you have to assign another variable float something, and then you have to perform 9 by 5. Then it will be assigned a value of 1.8. You cannot get the value 1.8 here actually. Correct?
Sir, if
So for
9.0 by 5.0, will it then be float, sir?
that depends on the compiler actually. From compiler to compiler, it will vary. But I don't think it should work. I have to check. I actually don't know. I have to check it. But normally, if you want to do it, you have to do it outside the evaluation scope actually. So just declare it like that. Float z. You have to check it by running the program. Okay, float z equal to 9.5, or maybe you can directly do it like that, 9 by 5. Then you will get 1.8. Then you can assign that value z here and get the value. But directly placing 9.5, 9.0 and 5.0, you have to check it. I don't know what will happen. Most likely it should not work. Okay. Okay, so these are the operations that you have to remember. And yeah. So yeah, the same thing. I'll come back later here. Because yeah. Okay, so now let's move to the 8-bit 2 complement representation. Okay. So this is important because the signed and unsigned, this actually confuses a lot of people actually, and it should be important to know how this works. So let's suppose that there is in the computer stores the signed integers using 8-bit 2's complement representation. So actually, what is 2's complement? That you have to understand first. So let us understand it. Suppose how many bits? 8-bit, right? So let's build a table with 8 bits, and in this table let us write the values. So this is to 0th position, so 2 to the power 0, correspondingly 2 to the power 1. This is actually to make you understand how the things is working. I'm writing this. From the next class, I'll just write it directly. Just a second. 2 to the power 4. 2 to the power 6. 2 to the power. So let's suppose this is the stored value 11110110 sorry 111011
1, 0. So what will be the equivalent of it actually? So to the power 1 is what? 2 plus 4. So 5 plus 16 plus the 5 is 32, 64 plus 128. So can anybody tell me what will be the value of it? 120 is plus 32 plus, sorry, 64 plus 32 plus 16. Just let me do the calculation in the calculator. We will talk. Also, you guys also do it. So 32 plus 2 by 6 is what? 64, right? Plus 32 plus 2 to the power 4 is 16 plus 4 plus 1. So it is 249, right? Can anybody confirm? Okay, so the binary representation is like that. So what is the 2's complement actually of it? So to calculate the 2's complement, you have to first invert the bits and then you have to add 1. Okay, so to calculate the 2's complement representation of it, what will you do? Sit here. 0, 0, 0, 0, 1, 0, 0, 1. So this is the first part of the 2's complement. After that, you add 1 to it. So you just add here 1. So this is 1. All the parts will be 0. 0, 0, 0, 0, 0, 0. So if you do the sum operation using the last two rows, insert row below, then it will be 0, right? 1, 1, 0. Then you take the carry over here. So it is 1. Again, you are getting 0 here. 1, 0, 0, 0, 0. So in 2's complement representation, it is basically you always have to take the leftmost digit as the sign digit. 0 means it is a positive number, and the remaining digit will tell you what is the value of the digit. So what is the value of the digit? 2 to the power 1 is what? Okay, so 2 to the power 3 plus 2 to the power 1, it is 10. And the value will be 10, right? So the value will be 10. But there in the option it is not written, so it should have been actually 10 instead of yeah, minus 10. So you understand, right, how it is happening? So firstly, sorry, it will be minus 10. I'll tell you the reason. Sorry. So whenever a number is written like this and it is said that it is a 2's complement number, you have to see the leftmost bit. If it is 1, then it is basically a negative number, and the other part will be basically the value of that number. So to convert that value of that number to the other part, what will you do? You basically take the whole number, you invert all the bits, and you add 1. So that whatever you will get will be the value of the number. So I did that exactly. So I took the number, right? This is the part, including the sign bit. So this is called the sign bit. I inverted it, flipped it. This is the 0, 1. I added it, and 10 I get. And as it is a negative number, because 1 is there at the leftmost bit, the actual value is minus 10, correct? So you get the value minus 10 here actually. Is it clear how the 2's complement representation is done in the computer? It is how it is represented. Then I'll proceed. Correct. Yeah, so let me proceed now. So this is the question actually now. So signed character x equal to 127, and remember that character is always 8-bit. So there are only 8 bits available. And then you are doing this operation x equal to x plus 1, and you are printing the value using the integer data type %d. So these are the options. Which will be the answer? What do you think? So please do it using the concept I just told you in the earlier slide. I'll give you 2 minutes. In 2 minutes, can you do it? Then I'll explain the solution. Look at it and try to do it yourself. Somebody has said 128. So take another minute. Okay. So what is the largest positive 8-bit signed number? It is a signed character, right? So if you represent it in a 8-bit system, you should always specify the sign. So as it is a positive number, 127, the sign bit should be 0, correct? So yeah, let me clarify it like that. It will be easier for you. So let's suppose this is the table, and how many bits are there? 8 bits, correct? In the system, there are 8 bits, and integers, sorry, the characters are represented in 8 bits. So in this 8 bits, the leftmost bit will be 0, always 0 or 1. And what is the largest possible 8-bit signed number? The signed bit will be 0, because it is a positive number. It should be positive number because it is the largest number. So you place 0 here. All the other position will be 1 because you want the largest number. And if you calculate the value, what will be the value of it? So 2 to the power 0 and to the power 1, 2, 3, 4, 5, 6, 7. So it is 64 plus 32 like that, and it will give you the value of 127. So you get the value of 127 like that, okay? And in the same time, at the same time, you add 1 with it. So let me add 1. So second, insert row below. So this will be the sign bit. It is always 1, sorry, 0, because you are adding 1 with it, right? So 1 is a positive number. You have to specify the positive number as having the 0 as the leftmost bit, and other position will be 0. Only at this position it will be 1, correct? So if you just add them up, what will be the value of addition? 1, 1, that will be 0 here. Then it will be 0 here on again, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0. So everything is 0, and at the last position it will be 1, and other positions will be 0. But if you get 1 like this, so let me do the operation here, summation. So the summation will be here 0, you will get 0 here also, 0, 0, 0, 0, 0, 1, correct? But if you see the 2's complement representation, at the leftmost bit, the value is now 1. For the other position, it is 0. So immediately you recognize that this summation is giving you a negative number, but the what is the value of that number? So you convert that 2's complement representation to binary again, right? Sorry, to decimal again. So how do you do that? You just flip it and add 1. So for flipping, you just take it like that: 1 1 1 1 1 1 1. So zeros, ones are flipped to zeros, zeros are flipped to ones. After that, you basically add 1 to it. So if you add 1 to it, 0 0 0, what will be the value actually? Tell me directly. If you add 1 to it, it will be, here will be 1 1 1 0. So it will be 0 1 1 0 0 1 1 0 0 0 0 0 0 1. So what is this? 128. And as the value was value content 1 at the leftmost position, it will be minus 128. So the output is minus 128. So is it clear, or it is too hard actually? Then I'll explain it again actually. Yeah, minus 128. Yes. So the protocol is basically to see whether it is signed or not. If it is signed, you just have to see whether it is a positive number or not. If it is a positive number, you have to place 0 at the leftmost position. If it is a negative number, you have to place 1 as the leftmost position. Okay, then you have to perform the operation as suggested. If you have to represent the values using 2's complement also. So as it is 1, I just took it like that. And if it is minus 1, let's say, I should have placed 1 here. Okay, then I have done the operation like this. After that, I got the value like this, but it is a 2's complement representation. So the leftmost bit is 1. So it is basically your sign bit. It tells you the value is negative. But to get the actual value, you have to just flip it and add 1, and you are getting basically 128. Correct? So that is how it works. It works actually. Now let's take another example like this. So in this example, let's suppose this is 81. Okay. So what will be the value of 81? Let me just a second. Okay. 2 to the power 0. This is the last question. But that we'll see in the next week. This part 2. The 4 to the power 5 to the power 6 to the power 7. Okay, so these are the values, and correspondingly, let's suppose this is the value we want to get, 81. So to get 81, this is the 64, right? So I have to place 160, I mean this portion here. Then I need 116, right? So what is the value now? 16 plus 64. Is it 70? No, 80. Then it will be 2.01, right? So this is the 81. Am I correct? 1 plus 16, 17. 17 plus 64. Okay. And this is your sign bit. As it is 81, I have assigned the value 0 here. Correct? Because it is a positive number. Then I'm inserting another row. Then I'm adding 1 here. Okay. So how to add 1? You just place 0 here, you place 1 here, and let's suppose I'm adding 2 now. Okay? So 1 here, 0 here. Remaining portion will be 0. Then let's perform the summation operation. It will be 1, it will be 1, it will be 0, 0, 1, 0, 1, 0. Now you see that the left bit is 0 actually. That means the performed A in 2's complement, it is a signed bit and it is a positive number actually. So now we have to convert the remaining portion into the normal binary representation. Okay. So how to do it? You just flip it. So 1, 0, 1, 0, 1, 1, 0, 0, and you add 1 to it again. So you add 1 to it. These are all zeros. 0, 0, 0, 0. If you add 1 to it, what will be the value? Correct. So it will be, just a second, 2 below. This is 1, this is 0, this is 1, this is 1, this is 0, 1, 0, 1. So what is this? 1 plus 4 plus 8 plus 32. So 32 plus 8 is what? 40. 40 plus 4 is 44 plus 1, 45 minus 45. Is it true, the calculation I have done? So will the value of 81 plus 2 is 45, or the calculation is wrong? So this is my question. So the calculation is wrong. The reason is that you don't need to do the flipping operation once the digit you get is a positive digit. Okay. So you just see the values and that will give you the final answer. So if you see the value, it is 64 plus it is how much it is? 16. So 70. Sorry, 80. 80 plus 2 is equal to 82 plus 1 equal to 83. So you'll just directly get the value. Now let's suppose that instead of 82, sorry, 0, it is 1. Then you have to do the 2's complement again to convert it into the positive number. But as you are directly getting the value and as the sign bit is 0, you don't need to do anything. Yeah, so this is the concept. So in the next class also we'll begin with the 2's complement because it's an important concept. After that, I'll show you the previous questions. Then, yeah. Any questions regarding this?
No, sir. Thank you.
Okay, thanks. Okay, so what about this actually? I already have 2 minutes of time. So just clarify this now. What about -2? As an exercise, can you do it quickly? X equal to this and this is -2. I think we don't have that much of time, so try to think about it. In the next class, we'll discuss. Okay, so how to do this operation. And in this operation, if anything is not clear, let me know. Yeah, every week it will be there, these classes.
My doubt is, sir, actually,
Yeah.
that main function we are denoting now, sir, main bracket.
Mm-hmm.
In any normal, can you show, sir, any code?
Main bracket. So yeah, it is not really necessary here. So you can just write it here like this also, float. Okay. Then just return 0.0. Doesn't
That
matter.
float return, I mean, this main is a function, and below this we are executing the statements now, right?
Correct. Main is a function that the compiler knows that it has to start executing from that position. Okay, and it will continue execute until the return statement is reached. That's it.
We have, sir, but when we are defining, in another example we have seen, sir, define function equal to x equal to x into x we have defined now, sir.
That is another function. Main function is the function where compiler starts the execution, and you can separately define other function also apart from the main. Main you have to define anyway. Inside the main function, everything will be there, and you have to separately. You can also separately define other functions. Okay.
That other function outside of the main, no, sir. So no problem, sir.
No problem. You can define anywhere in the program. Correct?
Yes, sir.
Okay, so I think it will require some more time to make you understand the 2's complement part. But yeah, I'll take another 15 minutes extra in the next class to make them clear. Okay. Assignment marks will be considered for the exams. I don't know how the exams will be, but yeah, assignment marks will be considered for the exams. Yes. Okay, I think you can stop now then. See you next week.